All right, back at it. Problem 10a. 2 marks looks like here. I'm going to show that these two things are equivalent by using some log properties. So let's get to it. So I'm going to set log base r squared of x equal to y1. And I'm also going to set log base, 1/2 log base r of x equal to y2. And I'm going to show y1 has to equal y2. So let's do some work. So in this case, I could put my equation in black here into exponential form, which would be r squared to the y1 would equal x. So r to the 2y1 would equal x. Let's do something similar over here to the red equation. This would be, let's see, I'm going to bring this 1/2 up as an exponent. So this would really be log base r of x to the 1/2. Oh boy, Apple Pencil, did you really? Okay, Apple Pencil just needed a stern talking to, but we got it. Okay, so now I can rewrite this expression in exponential form as well, which would be r to the y2 is equal to x to the 1/2. And then I could get x by itself, isolating it by squaring both sides. And would have this expression. Now, these two expressions are identical except for the notation y1, y2. So since r to the 2y1 is equal to x, and so is r to the 2y2, then y1 must equal y2, which means log base r squared of x then equals 1/2 log base r of x. Okay, let's see how we're going to use that in the next part here. Okay, so I see base 2 squared, base 2 squared. So I can do some manipulation here and call this 2 squared. So I can do a little bit of work with that, isolating it, making each of them equivalent to the other expression. So I'm going to leave the first logarithm, log base 2 of y, just as it is, and I'm going to reduce log base 4 of x to 1/2 log base 2 of x, as well as the third log there. That'll be 1/2 log base 2 of 2x. It says express y in terms of x. Well, that's going to be somewhat easy if I could compress these into one single logarithm. So I'm going to leave the first log as it is. The second one, I'm going to bring the 1/2 up as a power. That'll be square root of x. And the third one, same thing, bring the 1/2 up as a power. And that'll be log base 2 of root 2x. Okay, so let's see here. Now that I have all same bases, base 2, and I have the sum of all of these logs, then what that means is that I have log base 2 of y times square root x times square root 2x is equal to 0. So writing that logarithm then in exponential form, 2 to the 0, which is 1, is equal to y times root x times root 2x. Now I could make that relatively more compact and call that y times root 2 times x, because this can be root x times root 2 times root x is the same as root x times root 2x. And then root x times root x is just x. So it looks like y will equal 1 over root 2 x, which written in the form that they want would be y equals 1 over root 2. That would be p. X to the q, which would be negative 1. So q would equal negative 1. And p would equal 1 over root 2. All right, let's see what they got in store for us here on part C. Looks like it's 5 marks. The region R is bounded by the graph of the function found in part B. Okay, so that function is y equals 1 over root 2 x. We'll see if that's going to be better in that form. Oops, it should be root 2, and I goofed that up. That should just be an x. Uh-oh, that's going to hurt some feelings. 1 over root 2 x to the negative 1. Okay, it's bounded by the x-axis, the line x equals 1 and the line x equals a, where a is greater than 1, such that the area is root 2. So I'm going to set this up off camera and then I'll talk through it. All right, so here's what we got. We got our function, 1 over root 2, 1 over x. I'm choosing to write it this way because I'm going to integrate to find the area bounded by the graph. And that's going to come out to be ln of x. This form I don't like as much with recognizing ln of x, but it is what it is. We're going to integrate from 1 to some value alpha, where alpha is greater than 1. And we want the area to be equal to root 2. So let's do some algebra here. If you choose, you could pause the video and do your thing. But I want 1 over root 2 ln of x evaluated from 1 to alpha to equal root 2. Okay, so let's see here. What I'm going to do is I'm actually going to manipulate this and make the algebra a little bit easier for me. I'm going to multiply both sides by root 2, which will reduce this, and which will make that equal to 2. So I'm going to integrate ln from 1 to alpha, hoping that I can get 2 out of it. So that would be equal to, using the fundamental theorem, ln of alpha minus ln of 1. I want that to equal 2. Well, ln of 1 is 0, so I want ln of alpha to equal 2. Well, if I wrote that in exponential form, alpha would then equal e squared. It looks like I found the value of alpha such that the area under the curve called R is equal to root 2. Okay, guys, I think that's it. I think that's it for problem number 10. So, yet again, let me know if you got questions, and I hope you enjoy your day. See ya.